Honors Algebra students, Mr. Lawrence here with your flipped lesson, and I think you should be watching this on the weekend of May 3rd. I'll put that date at the top, May 3rd, either 4th or 5th. This is the weekend video. I'll expect you on May 6th to be ready after your Cinco de Mayo celebrations, to be ready to go. Remember, we are not stopping. The year is not over. After May 31st and we've completed the final, then we will stop. I know in some of your other classes you're feeling like, well, the year's just about over. It doesn't matter. In this class, it does matter. I cannot stress that enough. All right. In the last video, or in the last lesson, Miss Eubank taught you how to simplify RADs. Well, and I don't know if we use the definition, but the rad is the positive square root. So a rad, or this symbol, means the positive square root. Okay? So we're only dealing with the rads in this problem. And today we're going to learn how to do different operations, multiplication, division, addition, and subtraction involving rads. Okay? Now, one thing you need to know is that rad 3 times rad 12 is the same as, oops, I'm not in right mode, hold on, is the same as the rad of 3 times 12. Now some of you are going to go, hey, Mr. Lawrence, that's the same as 36, rad 36, and you're right, and then you're going to tell me the rad is positive 6. Okay. Now, there's another way to think about it, and sometimes it's smarter. On this one, I think this is a very intelligent way to do it. 3 times 12 is 36, and then you can take the rad of 36. It's a perfect square. But sometimes it's smarter to leave it in the multiplied form and then to break the 12 down even further. So, for example, I could break the 12 down into 3 times 2 times 2. Okay. Now in this problem, I don't think this is a great way to do it, but it works. Hold on, I lost my mouse. There it is. So I've got a pair of 3s. They get to go out on a date, right? I've got a pair of 2s. They get to go out on a date. And so I have 3 times 2, and that's going to be 6. All right. So see, I get the same answer either way. Sometimes it's smarter to do it the way I did this one, where I went across, and sometimes it's smarter to do the way I did the second time going down. Let's check out problem number 2 here. It's rad 5 times rad 15. Well, that, of course, is the same as rad of 5 times 15. This is going to be one where I'm not going to just multiply 5 times 15 because it ends up being 75, and I don't know the square root of 75 off the top of my head. I can estimate it, but it's actually an irrational number. So I'm going to break down the 15 because it's not prime into 5 times 3. And look at that, I've got a pair of 5s. They can go out on one date. The 3 doesn't have a partner. He's left at home washing his hair. So the product of rad 5 and rad 15 is 5 rad 3. Okay, an irrational number, but that's a simplified form of the answer. Okay, by the way, if you're wondering why there wasn't a rad on number 1, well, there was nobody left at home to wash their hair. Okay, now that being said, this division problem, the rad of 81/25, is the same as rad 81 over rad 25. Now we have a special rule in mathematics about how you can never have an irrational denominator. It's not going to matter in this problem. I'm just mentioning it because down the road I'm going to show you what to do with it if you do. All right, well, I know rad of 81 is a perfect square. It's 9. I know that the rad of 25 is 5, and so the rad of 81/25 is the same as 9/5. Remember, I'm only dealing with the positive square root. Okay, rad of 196 over 144 is the same as rad of 196 over the rad of 144. I know that rad 196 is 14 and the rad of 144 is 12. I have to simplify one more step, dividing the numerator and denominator by 2, and I get 7/6. Okay, you can always verify that in a calculator. Now, adding and subtracting is a little bit different. In some ways it's easier, and in some ways it's more work. Remember, in adding and subtracting, you always have to be thinking, do I have like terms? And in this case, the rads are going to be what tells you the like term. For example, this 5 rad 2 right here, that's kind of like saying 5x. The rad 2 is x. And this is a plain old x, 1x. Well, x plus 5x, that would equal 6x, wouldn't it? Well, rad 2 plus 5 rad 2 is going to equal 6 rad 2. You're just counting how many rad 2's you have. Pretty simple stuff if you think about it. Here I'm counting how many rad 7's. This tells me how many there are. There's 6 rad 7's here. And I'm losing 4 of my rad 7's. So I'll have 2 rad 7's left. Behaves just like the variable. Now that being said, we don't have like terms on problem number 7. But you know Miss Eubank taught you how to simplify rads. So I'm going to simplify this rad into 4 times 3. And I know 4 is the same as 2 times 2. So rad 12 is going to simplify to 2 rad 3. Now simplifying 27, I can do 9 times 3. And then of course I can turn that 9 into 3 times 3. And then there's times the other 3. A pair of 3's gets to go out on a date. The other 3 is left at home washing his hair. And look at that. I have 2 rad 3's. I have 3 rad 3's. I have like terms. I must have 5 rad 3's. There we go. All right, same thing on the remaining 3 problems. I'm going to simplify my rads, and then I'm going to see if I get like terms, and if I do, I'll put them together. Well, I know rad 125 is 25 times 5, and that'll be 5 times 5. Pair of 5's go out on one date. I have 5 rad 5. Now, if you're not sure how to break down 80, I mean, obviously 10 is a good choice, but you notice how there's a rad 5 stuck at home? There's a pretty good chance, if they're going to combine, that there's got to be a 5 involved. So I'm going to go ahead and divide 80 by 5. And I think that would be 5 times 16. And then 16 is a perfect square, 4 times 4. My 4's can go out on a date. The 5's left at home. Subtract. I'm going to get 1 rad 5, or better yet, just rad 5 as my answer. Either one I'll give credit for. All right, now you could have broken down 80 as, 10 times 18 and 2 times 5, and then what, 3 times 3 times 2, and then you got a pair of 3's going on a date, and you got a pair of 2's going on a date, and so you're going to end up with, ooh, do I have a mistake here? Oh, yeah, I do have a mistake. Excuse me. It's not 10 times 18. It's 10 times 8. Silly me. Sorry about that. Let me erase that. I was thinking 180, not 80. So 8 breaks down to 2 times 2 times 2. So you got a pair of 2's here going on a date. These 2's going on a date. So you have 2 times 2, rad 5, 4 rad 5. It's easier if you can get the largest perfect square as one of the factors. The largest perfect square, that is a factor. If you can get that right away, it makes the problems easier. All right, so 112 and 252. I'm thinking that if I break this one down, you know why I'm doing this one first? Because it's easier for me. I saw, no, that's not right. I thought it was easier. If I do it 2, what am I going to get there? I don't like 2. All right, we're going to have to do a little bit of work on this one. So half of 112. Actually, you know what? 4 is going to go into 112. You know how I know? It ends in a number. The last 2 digits are divisible by 12. So I'm going to do 112. I'm going to divide it by 4. And that's going to go in 28 times. So right now, I've got 112 as 4 times 28. Now, that's going to be, I'm going to leave that as a 4, because I know that 28 can be 4 times 7. Look at that, I got a pair of 4's, I got a 7. 112, rad 112 breaks down to 4 rad 7. All right, rad 252, again, 4 is going to go in. I'm going to try that 4 thing again. It worked pretty good that time. 252 divided by 4. It's going to go 63 times, I believe. So I'm going to have a 4 times 63. And I know 63 is going to break down into 9 times 7. All right, so I'm going to have a 3, a 3. Here I'm going to have a 2 and a 2. These 2's will go out on one date. These 3's will go out on one date. I'll be left with a 7 in the house. That's a good thing. And 2 times 3 is going to be 6. So 4 rad 7 plus 6 rad 7 will be 10 rad 7. The trick is you have to get good at simplifying things, breaking them down. All right, this will be an easy one because I know that half of 288 is 144. And I know that's 12 times 12. So I'm going to get 12 rad 2. Here, I'm going to have 2 times 100. This will break down to 10 times 10. I got a pair of 10s. I'm going to have 10 rad 2. Simplifying to rad 2. There we go. Pretty simple stuff. All right, we're going to get some practice with that in class, and then you guys should be getting pretty good at this. Remember that for addition and subtraction, you have to have like terms. For multiplication and division, you can break them down. All right, Mr. Lawrence signing off. Good night, everybody.